We are surrounded by these incredible feats of engineering every single day. But some of the most important ones, they're completely hidden from view. We're talking about the vast networks that keep our modern world flowing. And today, we're zeroing in on one specific, absolutely crucial component, the GRP pipe.
So let me ask you this. How is it possible that a massive multi-million-dollar construction project can be brought to its knees by something as basic as a pipe? It sounds crazy, right? But it happens way more often than you'd think, and the consequences can be disastrous. It just goes to show you the incredibly high stakes involved in getting our hidden infrastructure right the first time.
All right, so here's the game plan for today. First, we'll look at what happens when pipes fail. Then, we'll meet our modern solution, the GRP pipe. We're going to decode the technical language engineers use, see how these pipes are put through the ultimate strength test, watch them work in the real world, and finally, wrap up with why making the right choice is so critical.
Okay, let's dive right in. Section 1, when pipes go wrong. We're talking about the staggering cost of choosing the wrong pipeline.
And look, this isn't some rare freak accident. Industry analysis shows that this is a persistent, year-after-year problem. Picking the wrong pipe leads to leaks, bursts, and sometimes total system failure. We're talking millions of dollars down the drain, and essential public services put at risk. So, with that massive problem on the table, it's time to meet the hero of our story, the GRP pipe. This is truly a modern solution for our ever-growing infrastructure needs.
So what in the world is a GRP pipe? GRP stands for glass reinforced plastic, and the best way to think about it is like a high-tech recipe. You take these incredibly strong glass fibers and you fuse them together inside a super durable resin matrix. The result is this amazing composite material that is way, way stronger than any of its parts are on their own.
And this is exactly why engineers are turning to them. They're cost-effective, they're designed to last for over 50 years, and maybe most importantly, they are incredibly resistant to corrosion and chemicals, which, by the way, is one of the biggest weaknesses of older pipe materials.
Okay, now let's get into the nitty-gritty. To choose the right pipe, engineers have their own special language. So we're going to decode what I call the big 3 specifications that you absolutely need to know. First up, we've got DN. That stands for nominal diameter. Super simple. This is just the internal size of the pipe. Think of it like the number of lanes on a highway. A bigger DN means more traffic, or in this case, more water can flow through at once. It's the most basic measure of a pipe's capacity. Next is PN, the pressure rating. Now this tells you how much internal pressure the pipe can handle before it bursts. The perfect analogy is a soda bottle, right? It's built to contain all that fizzy pressure from the inside. PN makes sure the pipe can handle the force of whatever fluid is being pumped through it. And finally, there's SN, the stiffness class. This is all about external pressure. If PN is about bursting, SN is about being crushed. Imagine stepping on an empty soda can. That's an external load. SN measures how well a pipe can resist the weight of all the soil, the roads, and the traffic pushing down on it from above. But here's the really important part. An engineer doesn't just pick one of these numbers. They all work together. For any given pipe size, that's the DN, they can then choose from a whole range of pressure ratings and stiffness classes to perfectly match the job's requirements. It's all about mixing and matching. So let's see what those stiffness classes actually look like in the real world.
An SN of 2500 is your standard duty option. It's perfect for situations where the pipe isn't buried too deep and there isn't a lot of weight on top of it. Think about a water line running just under a sidewalk or through a park.
Now, if we step it up, we get to SN 5000. This is your heavy-duty, middle-of-the-road choice. It's designed for medium burial depths, where it has to handle the constant stress of city traffic rolling over it, day in and day out.
And for the most demanding jobs, you've got SN 10000. This is the super heavy-duty class. You pull this one out when you're burying a pipe way down deep, like underneath a major highway where the external forces are just absolutely massive. This pipe has to stay perfectly rigid and avoid being crushed, no matter what.
Okay, so having all these specifications on paper is one thing, but how do we actually know these pipes will perform the way they're supposed to? Well, that's where rigorous strength tests and international standards come into play. To guarantee quality, GRP pipes are put through an entire battery of tests. I mean, they're pressurized to their absolute limits to check their PN rating, and they are literally crushed to confirm their SN stiffness. It's a tough gauntlet that ensures every single pipe that leaves the factory lives up to its promise.
And this is why standards like the AWWA C950 are so critical. They're not just helpful suggestions. They're the frameworks that guarantee that a pipe you install today is going to work perfectly with no leaks 50 years from now. It's all about long-term peace of mind.
So, we've got all this technical knowledge under our belts. Now let's connect it back to the real world and see why these pipes have such a huge advantage out on the job site.
I mean, when you put them side by side with traditional materials like concrete or steel, the difference is just night and day. GRP pipes are so much lighter, which makes them way easier and cheaper to install. And crucially, they don't rust or corrode, which completely eliminates one of the main reasons old systems fail.
And all of that, the manufacturing, the easier transport, the quicker installation, the lower maintenance, it all adds up to this staggering number. When you look at the total picture, choosing GRP can slash overall project costs by up to 40%. For public works projects, that's a massive saving that frees up taxpayer money for other important things.
And this brings us to our final and most important point. The right choice really matters. Let's boil everything we've talked about down to the essential takeaway.
So, if you ever find yourself looking at a pipe's datasheet, here's your mental checklist. First, check the DN for flow capacity. Then, look at the PN for internal pressure and the SN for external load. And finally, make sure it meets key standards like ISO or AWA, and take a look at the joint type. Getting these few things right is the bedrock of a successful project.
So, the next time you turn on a tap, you'll know a little more about the incredible hidden network of engineering that might be working silently right under your feet. It kind of makes you wonder, right? What other invisible marvels are out there, keeping our world running smoothly every single day?